on new stuff today. Okay, so on the back of this, we actually did this. I don't remember doing this last week, but I'm going to multiply these two terms together that have these lovely rational. Not quite yesterday. I think we did it on Friday, but yes. Okay, so tell me what you would get if you multiplied this out. Like, what would you do? Okay. Mm-hmm. 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 Yeah, okay. Would it be plus or minus? Perfect. Okay. Here's the deal. Those two things, they're identical. You just do like a FOIL, all right? What if they're identical like that, but one's a plus and one's a minus? What'll always happen is these two guys in the middle always cancel each other out. One's a positive, one's a negative, so they're gone. Now, the other thing that happens here is when we do radical 7, you can always multiply those. That's going to be 49. It's always going to be subtraction because one was a plus and one was a minus, right? So that will be a perfect square. So really what you have here is 64 and then minus 7. No radicals left. Just go ahead and subtract those numbers. So this would just simplify to be a nice number. It's just 57. Those two numbers, what they're called and what's underneath here is just kind of explaining what those numbers are. They're called conjugates. So literally all it is, it's exactly the same, but one's a plus and one's a minus. That's called a conjugate. And it just tells you what that is here. Now, it gives you just in general form like a little proof of if you multiply these out, that all the radicals are going to get canceled. Always in the middle, you'll have a one that's a plus and one that's a minus. They'll go. And then on the other ends, you'll always have perfect squares or just a plain number. And so all the radicals cancel out. And these are used to rationalize the questions that we're going to do on this side of the lovely notes today. So the entire goal is to get rid of any radicals in the bottom of the lovely fraction, right? Now, this is very different from yesterday because I have pluses and minuses in these problems, whereas yesterday it was just things being multiplied. There was no plus or minus. All right, so I have 7 over 2 plus square root of 5. Okay, I'm just going to do the same thing we did yesterday. We're going to multiply by 1, but we're going to write 1 in a weird format. You're just going to do the conjugate of this. So you're just going to copy it down. If this is a plus, you just change it to be a minus. And whatever you do to the bottom, we're going to do the exact same thing to the top. So I'm going to multiply top and bottom by the conjugate of the denominator. When I do that, that's going to get rid of any radicals on the bottom. Okay? Now, some of these are just like a little distributive property. That's what this one's going to be. Some of them are actually like maybe you could do a FOIL. So what I usually do, and I know this is a little extra, but I just try and do the top and the bottom separately, and then I put them back together is what I do. So the top of the fraction is just going to be a distributive property. We're going to take 7 times 2 minus the square root of 5. And it's completely fine to have a radical in the top of the fraction. We don't need to worry about that. This is literally just 7 times 2, so 14, and then 7 times that negative square root of 5. If you take a number times a radical, typically what you'll see is that number will be written in front of the radical and then the radical, just so people don't confuse maybe that it's under the square root or not. So just be 14 minus 7 roots of 5. Okay, now the bottom.
Wait, so would it be 7 and cannot subtract this?
Can't subtract that because this would be like 14 minus 7x. You wouldn't put them together, right? So that's kind of the same concept. So it's 14 minus 7 roots of 5. So don't add those numbers together, just keep them separate. Okay, now the bottom of the fraction is literally what we just did at the top of the page. It's just different numbers. So I have 2 plus the square root of 5 and then 2 minus the square root of 5. As long as you've picked a conjugate, this should get rid of any radicals. If you understand this and you want to kind of not write out all this work, I'm totally fine with that, but I'm going to write it out here on the notes. All right, so 2 times 2 give you 4. Then you get minus 2 roots of 5. But then you should, if you're working with conjugates, turn around and get plus the same thing. So minus 2 roots of 5 plus 2 roots of 5. Always on the end, it should be negative because you got a positive radical 5, negative radical 5, so it's negative square root of 25. Okay, now here's what I have. The bottom of that fraction is literally 4. This would, square root of 25 would be 5. So it's literally 4 minus 5. Should always be subtraction between the two numbers if you're working with this. So the bottom of that fraction should just be negative 1. Okay, so then here's what I do to write my answer. I'm just going to put it back together. The top of the fraction is going to be 14 minus 7 roots of 5 over negative 1. Now, I would completely take that as your answer, or if you want to, and sometimes this happens, sometimes it doesn't, if you could actually divide the terms on top by what's on the denominator, you're allowed to do that. So like 14 divided by negative 1 would just be negative 14. Negative 7 divided by negative 1 would just change that into plus 7 roots of 5. So most of the problems you can't do that. Most of the problems you're going to have a numerator and denominator. But in that case, if you can actually divide, you are allowed to do that. So I would take either one of those answers. Is anybody having a question so far? Okay. So if I'm going to try to rationalize, and I have 8 minus the square root of 3 over 8 plus the square root of 3. Please don't look at that and go, oh, there's an 8 on the top and an 8 on the bottom and cross them out. You can't do that. Anytime there's adding or subtracting, that does not work. You have to rationalize the denominator by doing what we did in the last question. Can anybody just raise your hand and tell me, what would you multiply the top and the bottom of that fraction by to get rid of the radical on the bottom? Exactly. Okay, now this problem's kind of weird. So the conjugate of the bottom is actually what is in the numerator, but you guys will see it's only going to cancel the radicals on the top, or on the bottom, sorry. It's only going to cancel the radicals on the bottom. You will have a radical in the top. So the top of the fraction there, you're going to do 8 minus the square root of 3, 8 minus the square root of 3. Just a FOIL. If you like a box, you want to draw a box, do a box. All right, write this out though, because these are not conjugates. These are actually exactly the same thing. You're going to get 64, you get minus 8 roots of 3, then you're going to get another minus 8 roots of 3, and I will get a perfect square on the end here. You have negative square root of 3 times another negative square root of 3, so that's actually been positive, negative times a negative. 3 times 3 give you 9. Now, the terms in the middle here do not cancel out. That throws people off sometimes. They're both negative 8. So this would be 64, negative 8, so negative 16. I can combine them. They are like radicals. And then the square root of 9 there on the end is 3. The only other thing you could do there is actually add the two plain numbers, the 64 and the 3 together. So this would be 67 minus 16 roots of 3. Again, don't put the 67 and the 16 together. It's like 67 minus 16x. You wouldn't put those together, so don't put those together. They just stay separate. That's the top of the fraction. And then, real quick, I'll do the bottom. So now the bottom, we're multiplying conjugates together. So 8 plus root 3, 8 minus root 3. Can anybody tell me, maybe without foiling it all out, like what would you subtract there? Okay. Yeah, like what would I end up with left over after I canceled out the like terms? You're so close. He said 8 minus radical 9. What would I change about that?
8 minus 3.
The 3's right.
64.
There you go, yeah. Okay, no, you guys, and if you want, you can write it out. I'll just write it out real quick. Okay, 8 times 8 give you 64. Then you get minus 8 roots of 3, but then, because they're conjugates, you get turn around and get plus 8 radical 3. Now, on the end, it's going to be minus square root of 9. 3 times 3 is 9. It's always minus. These cancel, so you get 64 here minus 3. So don't for the first two, they get multiplied together. If that 8 was under a square root, then it would be 8. You'd be totally right. This would just give you 61. Now, nothing is going to reduce here, but I'm going to put this back together into a fraction. This will be a rationalized denominator because we won't have a radical in the bottom. Totally fine to have a radical in the top. The top of the fraction, or the numerator, was 67 minus 16 roots of 3. Can't do anything else there. The bottom is 61. in that case, I mean, if 67, 16, and 61 all have something in common, you might be able to reduce, but that really does not happen here. They don't have anything in common. And I know that looks really complicated, but your whole goal is no radicals in the bottom, so that is going to be your answer there, all simplified. Okay, I'm just going to try one more with you. So I've got 6 minus the square root of 2 over 7 plus the square root of 2. So I've got to get, you cannot cross those square roots of 2 out because of the adding and subtracting there. We got to rationalize by multiplying by the conjugate. What would you multiply this last problem by to get rid of the radical on the bottom? Yeah, 7 minus radical 2. All right, so top and bottom, I'm doing 7 minus radical 2. Whatever you do to the bottom, the identical thing has to go on the top because I'm really then just multiplying by 1. That's a super weird way to write the number 1, but then we're not changing the value of the expression. Okay, now the top I would write out, like either FOIL or box, whichever one is your preference. But I would make sure to write that out because these, in general, they don't usually have anything that cancels like they do with the conjugate. So write this one out. So like 6 times 7 is 42. Then you're going to get 6 times negative square root of 2. So it'd be negative 6 roots of 2. Just put the plain number out in front of the radical and then follow it by the radical. Negative square root of 2 times 7 would be negative 7 roots of 2. And then on the end here, we are going to get a perfect square for this one. Negative times a negative is going to make that positive. Under the square root, 2 times 2, this will become 4 because it's a perfect, or it'll be a perfect square. So what I have here, and I'm probably writing out more work than I need to, but I got 42. Now, the 6 and the 7, they're both negative. You can put these together. These are like radicals. So negative 6 minus 7, getting more negative. I got negative 13. Don't change what's under the radical if you're adding or subtracting. It's only outside. So this would be negative 13 roots of 2. And then square root of 4 is 2. So I can actually put that with the 42. So all done, the top of the fraction would be 44 minus 13 roots of 2. Again, you can't do anything more there. You would not, like if I had 13x, you wouldn't put that with the 44. So that's what you got going on there. Just don't subtract 13 from the 44. They have to stay separate. So this is your numerator. Okay, now my denominator, we're going to have 7 plus root 2, 7 minus root 2. If you understand this, you don't need to write it all out. Like if you can understand, like what should I be subtracting here? But if not, go ahead and do it. 7 times 7 will give you 49. 7 times that negative root 2, negative 7 roots of 2. If you're working with conjugates, you're just going to turn around and get exactly the same thing, but plus. So square root of 2 times 7, both of those positive, plus 7 roots of 2. These guys cancel each other out. On the end, it should always be subtraction if you're working with conjugates, because one's a plus and one's a minus. So it'd be minus the square root of 4. So all that's left here, I've got 49 minus the square root of 4, which should be a perfect square, which is 2. So then the bottom of the fraction is going to be 47. Okay, so my answer to the question, nothing simplifies here. It's 44 minus 13, whoops. Oh my goodness, I can't write. 13 roots of, fail. I'm going to start over. Okay, 44 minus 13 roots of 2, everybody over 47. And I know that looks really complicated, but that's the answer, getting rid of that radical.
How do you get the plus radical 4? I thought it was like minus radical.
On this one?
Yeah.
Okay, so see how they're both negative? So negative times a negative makes a positive.
Oh, okay.
And then 2 times 2 is where it's the 4. Yeah, now if they're conjugates, you got one of each, so it's a positive times a negative. But on this one, when I multiplied, it ended up being a negative times a negative. Really good question. Okay, anybody else have a question? Okay, I'm just going to ask you to do the back of the homework. So it's like 6 through 10.